I chose not to specifically belabor sort of what a beacon is, but I want to show you just a demo. I walk around with like a few in my pocket. So this is a beacon. It's about the size of like a half of a kiwi fruit or something like that. They're getting much smaller. So we introduced these about a year ago. And I'll give you just a quick demo of kind of how this works if I can hold my phone up. So if you see here this image on the phone, right? This is a little beacon. When I move the beacon, you can see this image moving. So it's a little bit, and if I hold my hand still again, then it holds still, right? So what's happening is this little device is intended to just sit on objects in venues, on a wall, wherever you want to place it. You could put it on your baby stroller and you could detect that your baby stroller is moving and it's out of range or something like that. Do I have a clicker, Andrew, or do you? Yeah. Cool. Awesome. So now that you've just sort of seen the beacon, what I want to do is just kind of skip past this stuff fairly quickly and go into a little bit about like the company, right? So we have about 5 people in New York. We're a little bit different company where we have a huge team overseas. We actually have 50 people in Europe. So it's kind of like the Israeli model. If you think about how Waze like came about, they had a huge team in Israel and they had like a smaller office in San Francisco. We've made this work with hardware and software, so it's an interesting challenge. Well,
we'll reconnect.
Cool. So it's been an interesting challenge building like a sort of what they call like a full stack hardware company. We've done most of what we do with these tiny little beacons kind of 100% internally, right? So we don't use someone like Scott Miller's Dragon Innovation and go overseas. We try to design the PCBs, we try to rev it, we try to build the firmware on top, make it updatable over the air, and ultimately we're not a consumer company. We're a little bit more like the B2B2C that is trying to get the consumer companies to integrate beacons into their new amazing things, right? So if you've heard of Tile, we're a little bit like Tile for developers. We don't want to sell the little keychain, but we want to make like 1 million tiles bloom, right? So I'm going to struggle just sort of talking about the slides, but I think I'm just to kind of maybe go into some of the things we're going to talk about here when the slides come back on, is I want to talk about not just beacons and what beacons can do, but the software and the services that you can enable with this technology. And the technology is capable of doing a lot. It's a little bit like GPS was 10 years ago. If you remember, way before Uber, before you had an iPhone and you're walking around and it was giving you a little bit of a blue dot on the phone, you had basically, right, no tool as a consumer, and the developers, there was no satellite that they could like tap into in the sky. So all the things you take for granted today around location didn't exist, right? So beacons, we think of them a little bit like satellite for indoors, and they're going to enable just a ton of new use cases. Awesome. So these are our next generation beacons, and these are actually about the size of like a dime. So I have one in my pocket in a Ziploc bag. This was the original generation, right? And they're yay big, and the next generation is literally a sticker, and you'll just kind of place it on an object. So a lot of time people think about beacons in the consumer use case, so we'll skip past this, right? This is the marketing narrative you hear a lot. This is just actually Virgin Atlantic and Heathrow is using our beacons to send a boarding pass or to help you when you're navigating through the airport. When you get to the gate, okay, great, instead of having to prove that you're who you are, you should just get a boarding pass just that pulls up that information to your phone right at the right moment, right? So I lost kind of the flow a little bit, but basically the whole thing that we're trying to build and what I'll show you here is that smartphones are incredible. You can stream ESPN live to your phone when you're walking like to the subway from Central Park. It's incredible, right? But they don't have any understanding, despite them being connected to the internet, of really like your location, right? And so they have this satellite in the sky but doesn't work indoors. So there's been like hacks such as like using Wi-Fi and using other like technologies to sort of sense generally where you are. But it doesn't extend the entire way to being able to just sort of do things that you would want to do around positioning and understand like the consumer journey through the physical world, right? So the vision would be if you pre-ordered a latte on like the Starbucks mobile app, that would be an amazing experience if Starbucks knew exactly when you were going to arrive. So if there were a beacon in the store, the beacon could power the barista's point of sale terminal and say, okay, now Steve's in the store, make his double latte. So these are the types of things that beacons are enabling. And I want to talk a little bit about the kind of the physics of it and what we're trying to tackle as a company around services on top that can enable exact positioning. So this is like very much a subtopic of beacons, but we think it's really fascinating, right? So the beacon itself is a small ARM processor with some flash memory, very extensible, but it's just a simple low-cost thing propagating a Bluetooth signal, right? And it's powered by a watch battery. And at the end of the day, sort of there's just a current going through an inductor, and I was a former electrical engineer, so it's fun to work on actual hardware again. And so, this is really just a way to sort of take and create a magnetic field and create electromagnetic radiation. And when you take current and you create electromagnetic radiation, what you're actually sort of doing is you're creating, like in the broad spectrum, some signal that your phone and your device can communicate with. And the way that we think about it, and the way I'll frame it, is that like if you are, as a human, sort of close your eyes for a second, right? Humans are just looking at, obviously, the visible light spectrum. We have this supercomputer, our brain, that we just take for granted that processes like everything and just terabytes of information. But if you close your eyes, you probably can't get out that door, right? So you'd have to relearn, you'd have to leverage your other, senses in order to kind of like just get by, but it would be infinitely difficult. So what smartphones are today is they're a little bit like, they're actually blind. So I'll play like, this is a 2-minute video, I'll play like maybe 45 seconds or a minute of it. Sorry, I thought Andrew was going to do that, but I got to do that now. Can't get the clicker up.
To give you context and help you navigate. As you walk, if you close your eyes for a moment, you can only walk a few steps before your brain loses its context and forces you to stop. So that's the world your smartphone lives in every day. It's a As you walk, your eyes process terabytes of information about the world around you. Your subconscious is constantly scanning for recognizable objects and locations to give you context and help you navigate. But if you close your eyes for a moment, you can only walk a few steps before your brain loses its context and forces you to stop. That's the world your smartphone lives in every day. It's a powerful computer, but it's completely blind. Last year, we introduced Estimote beacons to solve just that. They're small sensors that can be placed anywhere to provide context and microlocation to any smart device. Now, we're introducing Estimote stickers, tiny beacons with built-in accelerometers and temperature sensors. You can stick them to any of your favorite objects nearby. We call them miracles. Using stickers and our rich SDK.
I don't know what you were running. Do you mind throwing that up again? I'm like a little bit phased with the just sort of the flow of the prezo, so I'll try to end this with kind of like a little bit of a bang around what we're trying to accomplish, right? So the Bluetooth phone is sort of the device that is listening to the beacon, and by that analogy of sight, what we're effectively trying to do is give your smartphone eyes. So your smartphone, if there's beacons around, it can now detect and sense approximately where they are. And Apple built this amazing protocol to do just that. It's difficult though, because the antennas are non-standard. When I have the phone out, it's different than when I have it in my pocket, because there can be absorption of the actual RF. So the way that this has been kind of programmatically introduced to the world by Apple is through Ibeacon. And Ibeacon is just a way for the phone to sort of constantly scan and listen all the time around it for these little beacons, right? These little Bluetooth signals that the phone can parse and ignore ones that are not associated with some specific action, and then listen to ones that are meant, okay, I've walked into Starbucks and Starbucks is now gonna make my latte, or I'm in Virgin America at gate 52 and gate 52 is talking to me. And so it's really cool how they built this in. This is sort of the Ibeacon protocol. It's just a packet format that they said, hey, use this, developers, and sort of make your lives easier. And what happens is, just by shaking that beacon and you could see the phone moving, it's all resolved between the cloud and the client. So it's a pretty interesting way to take a very, very cheap, inexpensive piece of hardware, but that has to be updatable, has to be like intelligent enough to kind of understand what's going on around it and do things like maybe talk to other beacons and mesh network, but ultimately distribute the intelligence to the cloud, right? So this is a little bit harder to do when you're talking about radio waves, because the farther you get away from the source, the sort of fewer signals you're picking up. And again, like the metaphor for sight I think is powerful because we just take for granted that our eyes are extremely deft at processing just little bits of light. And right away I can classify objects, right? I know that I've never been in this room, I understand like who I've seen before. So this is the way that we're trying to contextualize the physical environment, and we think that by introducing multiple beacons and doing some creative things with them, we can actually build indoor positioning in an indoor physical environment. So the antenna, the radio waves in a typical beacon are propagated sort of spherical, right? And so in an ideal world, there's just like kind of this envelope of signal around it, but that's not the case. So what it really is it depends on the antenna design, and these are just a bunch of sort of boring shapes, but you can see depending on where you are in relation to the antenna, you're gonna have very different signal characteristics. This is actually Estimote's antenna. So we measure this in 3D way, and you can detect kind of the green and red blob is depending on the distance from the center, and you can see that it's not perfectly spherical, right? So this is the challenge around the antenna, and the antenna is actually that squiggly line on the beacon, which is in the lower left. That squiggly line on the right side of the circuit board is what we use in order to send out that signal. People ask about Android and other things too, because this is not just like an iOS only thing, but even Android is different because every handset is designed differently, and so the way that the signals reflect and go back and forth is pretty complicated. You're broadcasting the packet occasionally because you want these beacons to last for several years. You don't want them to die immediately. In Apple's case, they say, why don't you just send out every 100 milliseconds, which is 10 times per second. What actually happens then is when the packet is being read by the phone, there's a bunch of different interference patterns and things that can happen. And again, in an ideal world, you would understand that the beacon is on the wall 50 feet away, but it's a little bit more complex, right? So you actually have to smooth out the signal and try to figure out, like, do some noise reduction algorithms to detect, okay, now I'm like approximately here. So this is the level of kind of engineering work that we think is actually like uncharted territory around this indoor GPS technology that will make it pretty mainstream if solved, if you can create killer user experiences on top of it. So among the different things that happen to introduce noise in the system is you can just have absorption. So again, if there's a beacon there and I have my phone out, then it's gonna understand that I'm about that far away. But if I turn and my body is actually shielding from the beacon, in the lower right-hand, water absorbs Bluetooth signals. So they would just sort of be absorbed by your body, and that beacon would think you're farther away. But if I had many beacons around and I put my phone in my pocket, maybe you could design intelligence into the algorithm that it knows that I didn't just leave the room or flee. Maybe the algorithm understands that I just moved the position of the phone. So this problem becomes much more dramatic as you get farther from the source because of the way that I was explaining these like kind of panes here where you have like, I think on the left pane you have about 8 rays of sort of the electromagnetic radiation going through. On the right you can see that just extends to 1. So it's this 1 over r squared drop off, right? And that 1 over r squared drop off means that the farther you get away, it's extremely complex to actually try to accurately estimate the distance. So what we're doing is we're looking at a couple algorithms, right? And this is really interesting because the community is also building things on top of Estimote. We have like 25,000 developers now that are just building apps and buying hardware from us and testing and tinkering. And one thing that goes along with that is they just upload code to GitHub, right? And they just like create some algorithm. So I think it was a Twitter engineer that created a trilateration or triangulation piece of code on top of Estimote and just uploaded it for the universe, for the world, for the other developer communities just to go and hack on top of that with. What we're trying to do is extend that a little bit to the next level, where we take these 2 different types of orientations, like which could be the one I just showed you, which is taking like distance from multiple beacons and being able to estimate. It's actually partly why we have the name Estimote. the distance between them, and then just do some data science, right? So we have a team of actually 4 or 5 people working on just this product now. It's a product team for us. It's indoor positioning, and there's a couple data science people that are not only taking beacons, but are also using, obviously the available sensors on the phone, so the gyroscope, accelerometer, and compass. And we have a demo down now where you can walk through a room like this by placing multiple beacons, and you can see like a blue dot on a map. So it's really exciting. I saw it for the first time a few weeks ago, and my mind was blown. This is another approach that you can have to positioning. And if you think about this as a little bit more like narrow cells, and each one of these different circles would be the distance that that individual beacon in the center of the circle would cover. So by dialing down the distance that they would cover, you could then detect, okay, I know as a user, the phone there, like if that user is moving through the physical space, then they've moved from one area to the next, right? And those would be like kind of the cell approach. But at the end of the day, you don't want to put 100 beacons up in a space like this in order to do positioning. You want to put like 5 or 10. So super happy to talk about this product because I think like we're excited about announcing this to the world in not too long, and it's just basically our indoor positioning SDK. We'd love for people like Dave at Floored to use this if there's value in it and being able to see objects in the 3D space, or maybe where users are actually moving through the areas that they're staying longest in. So these are actual screenshots of our product that's coming out. And the way that this product will work is you will take multiple beacons and you will just calibrate physical space. So in this space here, this is probably 70 feet from this wall, and this is like another 60 feet. We'd take maybe 4 or maybe 9 beacons, and you would just place them around. And this is just showing the end result on the left of a screenshot of the user then in the middle of that space. So if I were to travel through it with a few feet of accuracy, you can actually see where the user is, right? So this unlocks a lot of new incredible use cases. We don't know what exactly they'll be, but we also didn't know Uber was going to be like a killer service on top of GPS, right? We just don't know. And so I think as a platform, it's a little bit early. The Ibeacon space is interesting, right? Apple came out with a bunch of new things today around payments as well. But Ibeacon and just generally the idea of proximity-based location awareness is very immature. And so we think that if we can turn over tools to developers to build services on top of beacons, there's going to be some incredible things. This is really cool. So this second screenshot is basically you can then you can get that code, right? So on the left, this is just an example app that we're going to have in the App Store. But as a developer, you're going to want that code in your space, right? And in your app, and you're going to want to integrate that in your mall or like into the MoMA or like wherever you're building. And then on the right, this is a screenshot of just something kind of cute that our team came up with, which is you can actually do a trace so that someone drew a heart, and you could sort of share this to like Twitter or Facebook, right? So I think a lot of times one thing that's overlooked around just companies generally in tech, and especially if you're close to the consumer, is how to build a brand. So like the type of branding that Jake's done with electric objects, that's super hard to do, where people are like coming to you and paying attention to you and buying your stuff on Kickstarter. We're a little bit different. We're this developer orientation, but we're like super focused on kind of being available for developers, and that includes inspiring them. So we think about it just as the first time you sort of downloaded Instagram or something as a consumer. You probably just saw 10 people using it and eventually like downloaded it. The developers, they tune into what each other are doing. So if somebody shares a screenshot of the indoor positioning product at Twitter, something that people do a Twitter search, and they're like, okay, Estimote's doing cool things on top of beacons as a service, it can be pretty powerful for the brand. That's all I got. Sorry for the initial.
Thank you, terrific job. Sorry for the technical difficulties. As we are about a minute away from the food and the beer, time for one question. I should have positioned it that way. Yes, there.
Hi, I'm Kunal Tandon, and in light of today's announcements from Apple and iOS 8's focus on notifications, how do you anticipate that beacons can kind of leverage telling people about their spaces rather than specific actions?
Yeah, are you talking about sort of around also just something like around the payments or like the watch or specifically or just generally?
Well, I think rather than, you know, you gave examples of if someone walks into Starbucks or something, that's like kind of a beacon then leading to an action.
Yeah.
Now that there's going to be more passive notifications that don't require you to open an app or something, do you think that beacons can be leveraged to kind of just inform people about where they are?
Yeah, I think so. I mean, the beacons, the powerful thing about notifications when done right is that you'll engage with them and act, right, and interact. And so they gave an example during the keynote today of like OpenTable. And the OpenTable integration is actually really interesting, I think, through the user flow, right? Because with OpenTable, you've just gotten a reservation and then you've arrived at the restaurant. You don't do anything as a consumer, right? You don't pay through OpenTable. So when they talked about payments through OpenTable and you could use the fingerprint reader to sort of authorize that, what they're implying is that there's a new product, I think, in trial from OpenTable that you would just store your credit card credentials and you would just leave the restaurant without paying, right? So that's awesome. So what beacons would do there is beacons will notify you when you walk in, hey, you know, we've checked you in at the host. With 100% certainty, they know you're in the restaurant. And they're like, hey, go and hang out by the bar. The host knows you're here, right? And they tell the host whom is running an iPad, you know, that Steve is in the restaurant. And then the flow through that can just basically, like, the entire process should just be, it should be aware enough to, in order to give you notifications at the right time or to like suppress them at the right time. So there's a startup in New York called Cover, whom we reference sometimes because they're doing really cool things with Ibeacon. I think they measured that like 600 or 700% increase in people actually using Cover in the restaurant, that they'd already downloaded it just because they were sending a notification and saying, hey, you're at Charlie Bird or you're at, you know, La Paine or something, right? Because as a user, you wouldn't necessarily remember that the place you're in, there's something like around it that's really, that can happen, that can unlock kind of potential in the venue. So it's a little bit early, but there's people coming up with some crazy stuff right now, yeah.
That's all that we have. Thank you so much.